Hello everyone, welcome back to my channel. Before starting the video, let us first understand some important background concept related to today's topic. Why do some sensors becomes completely useless even though they are working perfectly? Think about your smartphone. It says it has 4 cameras, but what if 3 of those cameras are just copying the main camera? Would they really add new information or they just increasing the number? Now imagine the same thing happening in a factory. You install a 4 sensors, but in mathematically, only one of them is doing a real work. The other 3, they are just copies. How do we detect this mathematically? And how does this idea help in machine learning and AI? In today's video, we are going to understand why some sensors are useless using a powerful concept called linear dependency. I will try to explain it in the simplest way as possible. But before we solve the census problem, let us first understand the three important ideas. First one is redundancy, second one is linear dependency, third one is matrix rank. First one, redundancy. Redundancy means repeating the same information without adding any new value. Example, imagine your phone source. Your phone shows time in different format, time in 24-hour format, time in 12-hour format, but both represent the same time. That is known as redundancy. Second one, linear dependency. A set of vectors or sensor readings is linear dependent if one can be written as multiple or combination of others. Example, imagine three water tanks measuring the water level. Tank 2 always shows the double the reading of tank 1. Tank 3 always shows the triple the reading of tank 1. They are not measuring the water levels, they are just scaled copies. So, tank 2 and tank 3 are linearly dependent on tank 1. Here, tank 1 is the independent. So, this is known as linear dependency. Third one, matrix rank. Matrix rank is the number of independent pieces of information in a matrix. Example, suppose you have 5 students marks, maths, physics, chemistry and total marks. If total marks equal to maths plus physics plus chemistry, then total does not add in new information. Total is dependent on maths, physics, chemistry. Even though there are 4 columns like maths, physics, chemistry, and total marks, only 3 are independent. Independent are maths, physics, chemistry. So rank is 3. Now let us solve one case study. Online learning platform analytics problem statement. An online learning platform tracks engagement and performance in order to improve course recommendation. For each student, the platform records the following features. The features are first one, total hours spent learning, second one, average time spent per lecturer in hours, third one, number of lecturers watched, fourth one, final performance score. By applying learning, analytics, and machine learning models, the platform wants to reduce the dimensionality of dataset without losing meaningful information about student learning, behavior, and performance. Given data matrix x equal to this is future 1, so considered as f1. This is future 2, considered as f2. This is future 3, considered as f3. This is future 4, considered as f4. So f1 equal to 20, 30, 24, 40, 36. F2 equal to 2, 3, 2, 4, 3. F3 equal to 10, 10, 12, 10, 12. F4 equal to 85, 90, 88, 92, 89. Each row represents a student and each column represents one recorded future. Task first one, interpret the relationship among the first three engagement related futures using logical and mathematical reasoning. Second one, determine whether the dataset contains redundant features. Third one, find the rank of the data matrix X. Fourth one, identify minimum set of feature that can represent the dataset without loss of learning behavior information. Fifth one, explain how removing redundant feature helps in data handling high dimensional education data. This is question. Let us solve the question. Step 1, write the data matrix. X equal to, we already known, this is F1, this is F2, this is F3, this is F4. F1 equal to 20, 30, 24, 40, 36. F2 equal to 2, 3, 2, 4, 3. F3 equal to 10, 10, 12, 10, 12. F4 equal to 85, 90, 88, 92, 89. Now column futures. F1 equal to total hours spent in learning. This is F1. F2 equal to average time spent per lecture in hour. This is F2. F3 equal to number of lecture watched. This is F3. F4 equal to final performance score. This is F4. This is step 1. Step 2, logical thinking. F1, that means F1 equal to dot average time spent per lecturer, that is F2 into number of lectures watched, F3. By multiplying F2 and F3 we will get F1. This is logical thinking. Step 2. Step 3, checking linear dependency or mathematical thinking. F1 equal to F2 into F3, where F2 equal to 2, 3, 2, 4, 3, F3 equal to 10, 10, 12, 10, 12, F4 equal to 85, 90, 88, 92, 89. F2, F3, F4 does not show any new pattern like F1, but F1 is dependent on F2 and F3. So F1 is dependent and F2, F3, F4 are independent. This is known as linear dependency. Step 4, rank. Rank equal to number of linear independent columns. Here F2, F3, F4 are independent. So they are 3. So rank is 3. Step 5. Identify redundant future. Redundant equal to future minus rank. Futures are total futures are 1, 2, 3, 4. 4 futures. So futures are 4. We got rank equal to 3. So rank equal to 3. By using the redundant formula, futures minus rank 4 minus 3 equal to 1. Redundant is 1. Step 6, minimum futures required. Minimum futures required equal to number of independent futures. They are average time spent per lecture F2, number of lectures watches F3, final performance score F4. These are the independent, not dependent. So minimum future required for that is F2, F3, F4. Step 7, interpretation, that is final output. Rank of matrix is 3. Redundancy futures is 1. So minimum futures set required is 3. Only F2, F3, F4 are required. Step 8, conclusion. 4 futures are recorded in a given matrix data, but only 3 futures are independent. They are F2, F3, F4, and F4. And F1 is independent because by multiplying F2 and F3 we get F1. So we need 3 futures F2, F3, F4. F1 is not necessary. Thank you. So today we learned that more sensors do not always mean more information. If one sensor can return as a multiple of another, it becomes linear dependent and does not add any new value. In our example, even though we have 4 sensors, only one is truly independent, just like a phone with multiple cameras. If they are just copying the main camera, they don't add any real information. So always remember, it's not about how much data we have, it's about how much independent information we have. Thank you for watching.